Hello viewers, welcome back to my channel. Today I will show you how to draw box plot in two-way ANOVA and how can you add the letters in case of RCBD design two-way ANOVA 2 factorial experiment. In our previous video I showed that in pairwise comparison by using 2K SSD we get different letters for treatment and variety interaction. I used three varieties: variety 1, variety 2, variety 3, and as a treatment used the control and water logging C and W. So these are the lettering. Now I will show how to make a box plot and how can you add these letters in your box plot in case of two-way ANOVA. First we can store the information at bx, that is for box plot, and then you can box plot, right, and dependent variable plant height, then tilde. Okay, and right side of tilde will be the independent variable. Here we use the treatment and variety interaction, and then our data will be stored as x, and then we don't want to make the plot at this moment. Why, I will explain it. Plot equal false. Actually we don't need to draw the plot at this moment, but we need to save the information of this box plot as bx. We can use it because we don't want our box plot moment. We need to align it with the letters and also colors, different color for different varieties. Okay, we can run it. Yeah, everything is okay. Then as I told, we need to assign different colors for variety colors, variety COLS, right. Variety colors will be C function. We need different variety in different color for different varieties. For variety 1, sky blue, okay, and for variety 2 the color will be orange, and for variety 3 color can be light green, right. Okay, this will be the color of the varieties, and we can fix it as names just to name the object. We can name it variety colors, right, and that can store as okay. Labels. Why we need to labels this? Because the varieties 1, 2, 3, it should be in chronological way: v1 sky blue, v2 orange, and v3 light. So $sign variety, right. Now it's in label, and now we can check the box of the names, right. Okay, now we can check the names of our box plot interaction. This one is here: CV1 WV1, CV2 WV2. That means the variety 1 control, variety 2 variety 1 water logging, variety 2 control, and variety 2 water logging. If you look closely, you have seen that there is something that is the control before the variety dot, before dot, that is the control, before dot, that is the water logging. We don't need this control and water logging treatment. We need only v1 and v2 and v3 because we want to assign the colors of these three varieties. So we need to remove this information. For this we need some extra codes. I will show you. It's the box color. Okay, that will be the box color. Okay, I will explain, don't worry. Just for saving times, I'm copying and pasting here. Box plot is here. We use the sapply. This is the simplified apply. Why use it? simplified apply, because we want to apply a function to each element of a vector. That means we want to send the information of bx names. These are the bx names. This information we want to distribute, what we want to send it in nm, that all information will be saved there. That's why we keep it as the function nm. And then our variety will be the sub. Why you use sub here? You have seen the pattern replacement x. That means we can replace or we can change any of the information we need. That's why use the sub here. Here we want to replace or we want to change the information before dot, so you want to keep only after dot. For example, this one stands for replace everything up to the dot. That means in the whole one is replace everything up to the dot, and the first two, this one is all the everything, any character or any length, dot star means, and then double backslash dot. In R, backslash means escape, double backslash dot means escape dot. So in this area, everything means replace everything up to the dot. And then here the replace, we don't want to replace everything, you don't want anything to replace. Then here is nm is our information, that is this information. So what it will do, it will replace, or it will not replace, it will escape everything before dot, so it will keep after dot. And then our variety colors will be the variety this one. Okay, now we can run it. Right, now we keep the all information. Now we can draw the box plot. So every information done. So now we can draw the box plot. Here the dependent variable pH, independent variable variety and treatment, as I told earlier, data is x, and what will be the y limit, that is the function of minimum plant height -2, that is our y bar will be the lower between between the mean before the minimum value of the plant height and the maximum plant height, it will be 2 plus up, so that there will be some space in y-axis, so that we can use the letter or everything whatever we want. And the color will be the box color, and x labeling is nothing here, but you can use the treatment or whatever you can use. And y labeling plant height main, that is the title of the box plot. Here I gave it as effect of treatment and variety. You can change it if you want. Okay, this is our box plot, and now we have look, you can see that variety 1 is in sky blue color, and variety 2 orange, and variety 3 in light green color. Okay, now I need legend so that I can easily check this. So for this, okay, just copying it here. Okay, right. Okay, this is the legend top right, that means it will be in here, but if you want you can change it in top left or bottom left as you wish. And then legend will be the levels of variety according to variety, and it will fill on the basis of variety colors. And box type will be n. Why I use n? N means this remove the border of box around the legend around, there will be no box. But if you want you can give 1, and 1 will show the border of the color. I will border of the legend, I'll show it. First I'm showing it here. Okay, right, you have seen variety 1, variety 2, variety 3. This is the legend. As I told earlier that we can use 1 to change the border. Okay, now there is border here, so as you wish you can do it. Now it's time to add the letter. Before adding the letter we need to maximize the value, right? This code we need. Okay, so before adding the letter we have to uh, fix the maximum value of our character. For this, maximum value will be the t apply. Why use t apply? Because t apply x index is treatment group, fun in functional. Okay, so to subset the uh, information of a vector, to subset the information, so here the function is maximum, that is the maximum value is subset or distributed among the all treatment groups. That is the meaning of this quotes. And then we order the treatment order on the basis of our treatment variety interaction, and the later vectors on the basis of the two key groups, and then it will be according to or treatment order and groups you can write it. And then just simply, okay, this three we can run it, right? Everything is okay. And then for text, x will be the sequence along. In my previous video, in case of one-way ANOVA, I explained it. If you want you can watch that video for better understanding. Sequence along is to arrange the sequences, and maximum value y will be the maximum value of treatment order. And for keeping space, this is the space among the box plot, between the box plot and the letter. So you can keep it a little bit upper if you want, that is the distance between the box plot and the letter. And the labels will be the letter vector. Okay, we can run it. Now we have seen the letter on the top of the box plot nicely. So that's how we can make a box plot with the letter. And then you can zoom it for better understanding, and you can copy it from here, or you can export it, right, as image. Whatever image you can change, pns or gps or whatever. Okay, and then or you can save it as pdf. Thank you very much for watching.